do. That. Bum, ba-dum. Oh, did you walk? That's better. La, 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 la. And if you need me to zoom in on any of this, let me know. Let me see here real fast. Yesterday was this. Oh, sorry. That's the wrong thing. Let's put that over here. Let's do this. Let's do this. Yeah, there we go. Perfect. Okay. How are we doing on this? Pretty good? Yeah? Are there any of these that you need to ask about, or hopefully you realize that's the first page and the second page, like I got it divided up here. Yeah.
44 and 48 on the first.
44 and 48?
Yeah.
Okay, we'll look at those in a second. We'll write these down. 44 and 48. You need me to zoom in on something for you there, Stacy?
Yeah, the number 44.
I can do that. Is that better?
Yes, thank you.
You bet. Let me go ahead and do that. So we're gonna do these two here. Anybody else want any of these done? Off either page?
32 on the second.
32 on the second one. Look at that. Oh, man. Dun, 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 dun. Okay. So let's do some problemos here. So let's start on page 446, 448. We'll look at 44 and 48. Is everybody done checking here? We're good? Okay. I'm going to bring this over here. This is where we were at. So let's see, number 44 in the first section. Beautiful. I'm glad you asked, because this is leading into one of the things we need to do today. It's got this thing. And it goes I equals 3 to 9. And then it's got 72 minus 6i over here. Okay, so what this is known as is summation notation. This right here is the Greek letter sigma, okay? So this can be called either sigma notation
or it can be called summation notation. All right, either one of those it can be called. Now, what is it telling me to do? What it's asking me to do is add up terms 3 through 9. That's what it's asking me to do. Now, what we did yesterday was we did like, I would put S and I'd have a subscript. If I had this, that would be asking you to find the sum of terms 1 through 9. But let's say I don't want the first ones. I don't want sum of 1 through 9. I want to go from 3 through 9. This is a way of writing it. This sigma notation, summation notation, all right? This tells us the first term we're going to use in the sum. This tells us the last term we're going to use in the sum. So what this would be doing is I would have to literally find, I'd have to plug in 3, then I'd plug in 4. So if I wrote this out, it would look something like this. It would be 72 minus 6 times 3, plus the next one would be 72 minus 6 times 4, plus the next one will be 72 minus 6 times 5, plus the next one will be 72 minus 6 times 6. That's what I'm asking you to do. That's what this is asking you to do. Okay? Now guess what? You don't want to have to do that by hand, do you? Not at all. So the beauty is you can actually do this on graphing calculators and Desmos. Okay? So if I'm going to do it both, I'll show you both ways. So if you're using a graphing calculator, right? And if I'll do Desmos next. Okay. So let me bring this over here. All right. Let me clear this out. So when you're looking at this, if you hit your alpha button here, okay, and I hit the window button, that was where we found the log base button. Remember that one over here? That's how we did log of any base. Look up here at number 2. Number 2 says summation. So I'm going to hit the number 2, and what shows up on my screen is exactly what is on the board. I just have to type it in. Now, on the 84, if you're using a graphing calculator, what you do here is you always type the variable x. So I'm going to put x, and it's going to go from 3. Now I have to hit the right area to get to the top. Okay? So this is the lower index of summation. This is the upper index, 9. So I'm going to add terms 3 through 9. And then over here, I literally put down what the rule is for the nth term. I have to use this variable. So I'm not going to put 72 minus 6i. I'm going to put 72 minus 6x. Get out of that, hit enter, and boom, there's the answer, 252. All right? So it literally adds those up for me. Literally will add them up for me. Okay? Now, if you're doing it on Desmos, so this is the Desmos people now. So let me click this and open up a Desmos tab.
Minus 6.
Boop, mute that. Gotta move this out of the way. Where's that at? There we go. Okay. All right. So I'm going to hit start practice. There we go. Boom. Here it is. Now, I'm going to have to use the online keyboard. So I'm going to come down here to this little keyboard and open it up. And I'm going to go over to this function button here and click it. And I'm going to go to miscellaneous. And down at the very bottom in the center, you will see the sigma, the Greek letter sigma again. I'm going to click it. And again, I get this. Now this time, it already gives me the letter n. So I'm going to put what? N equals 3. Okay. I can hit the tab button and it goes up here. 9. Tab out. Now I have to put the rule here. Okay. Now, I can't remember what was the rule. 72
minus 6.
72 minus 6n. Okay. So 72 minus 6n. All right. Now let's see what happens. Doesn't do anything. Why not?
You need parentheses.
I need parentheses, correct. Because otherwise it's just thinking that it's 72. So it's parentheses here and parentheses there. Let's get rid of this. And there's the answer, 252. So you can do that on a graphing calculator, or you can do it on Desmos, this sigma notation / summation notation. All right? So that's what you're able to do using this, and it makes it a lot easier for you. Okay, and this is nice when you're not adding up the first term to a certain term. So if I said, hey, I only want you to add up terms 10 through 15, then you would want to use this method here instead. All right, you'd want to use this method here instead. All righty. You want me to do the other one too? Is that okay, Brady?
Yeah, that's fine.
So if I did the one for you, okay. All right. Does that also take care of number 32 for you on the other page?
Yeah.
That they're all the same. Anybody else have any questions? Yep. 58. Okay. That's on the second page.
Yeah.
The soccer problem. Okay, let me read this out loud. We'll talk about it here. It says a regional soccer tournament has 64 participating teams. In the first round of the tournament, 32 games are played. In each successive round, the number of games played decreases by a factor of 1/2. Factor, geometric then, okay? So let's just think about this. So our first round, first term is 32 games. In the second round, there are 16. That means in the third round, there would be 8 games, all right? Fourth, there would be 4. Fifth, there would be 2. And then after that, would there be any more games? No, there wouldn't be any more games, right? Okay. So it says, find a rule for the number of games played in the nth round, all right? So the rule would be what? A sub n. What is the common ratio? R is what? 1/2. So how did we write this rule? It was the first term times the common ratio raised to the n minus 1. So there's the rule for that. Okay, so there's our rule that we need now. Then it says in here, find the total number of games played in the regional soccer tournament. Now, if I wanted, I could, since it's not a lot of numbers, I could just add these up in my head. And I would do it like this. 32 and 8 is 40. Here's another 20, that's 60, plus 2 is 62. But let's say you had more teams, then maybe you wouldn't do this. Or maybe some other scenario where I could make it harder. Let's use the rule. So I'm asking you to find the sum of how many games. How many rounds are there? You have to know that. So what is it? It's the what? The sum of how many rounds are there?
Wasn't there be another one?
Shouldn't there be 6?
I don't know. Should there be another one?
Yes.
Oh, yeah, there's one more. Okay, so I'm finding the sum of 6 rounds is what I'm finding here. All righty. Now, if I use the method from yesterday for a geometric series, what goes here? What goes here? Parentheses. This is a 1 minus. This is a 1 minus. Help me out. What went out here? Is it the first term? Or is it the number of terms?
Yeah, but no, it's 6.
It's what?
It's 6.
It's 6. Oh, okay, so it's 6. What goes in here then? 1 minus what? R. And then it goes to the what power? N. So what's going to go in here is 1/2 to the n power, or should say 1/2 to the 6th power, then it's over 1 minus 1/2. Now, this is what I said yesterday. This is when it gets more gross because you get a fraction in there. All right, 6 times. Let's talk about this in here. The bottom part's easy. What's 1 minus 1/2? That's 1/2. All right. In the numerator, you're going to get 1 minus. Now, when I take a fraction to a power, you take the top and the bottom to that power. Well, 1 to the 6th power is easy enough. That's 1. 2 to the 6th power is 64. Okay, we're going to keep going with this. Let me go ahead and go like this so I can see everything. So that is 6 times, guess what I'm going to make this? 64 over 64. And I should be able to do this in my head. 64 minus 1 is what? 63. So it's 63 over 64 over 1 over 2. All right. This right here, when you're doing a fraction over fraction, your numerator is the product of the extreme values. Now, when I say that, that means these two here. That's going to be your numerator, the product of those. So it's 2 times 63 over, it's the product of these here. 64 times 1. Okay. Now what? Now what would I do with that? Simplify it. Okay. Tell me what I would do next.
2 times 63.
I could do 2 times 63 next, yeah? Let me ask you this. Would this be okay to think of this as 6 times 2 times 63 all over 64? Is that true? Is that what it's going to be? Yes, Grace?
Yeah.
Yeah, okay. Let's go ahead. I'm going to extend my page here. Now, all right. What do you think? What did I do with that? I'm looking for something. I sit down. Tell me, guys, you can do basic math, can't you? This is just arithmetic.
756.
756 over 64. Okay. I stuck it in my book. I'm looking for this problem I wanted to do with you guys today. If I don't find it, we can't do it, and that's a problem. So, you guys are liking everything I did? I don't know where the problem is.
No.
I don't like what you guys have told me to do from the very beginning of this. But I just did it because you guys told me to do it. You guys told me to do it. I said, what do I do? What goes here? What goes here? Let's go back and talk. I went along with it. Probably shouldn't have, but I went along with it. What's wrong? Yeah, Ryan?
I just flipped. So like
You flipped it.
63 over 64 times 2.
Well, that's the same as this. That gives you this.
And then I got 63 over 32.
Right, because I can take this 2 here and make it a 1 and add a 32. It would be the same thing. Is there anything else about this I don't like? Yeah.
Which step did we mess up?
I don't know. You guys have your notes out, don't you?
Yeah.
As long as you have your notes out, you can tell me where we're going wrong. We got. Look, is that a whole number at the bottom when I get done? Was this?
No, it wasn't.
Is that a whole number?
Like 1120.
There's no way you're playing partial games. Correct? There's no way you're playing a partial game in this. Come on. I know it has to be a whole number, guys.
We get the 6 supposed to be 32.
What?
The 6.
Yes. That is not n. That is a sub 1. And that's why I asked you guys. You said it, but guess what? A lot of people said 6. I said, okay, fine, 6. Not 6. You're thinking of the wrong one. That's arithmetic. That's the arithmetic one, okay? So for us, this 6 should not be a 6. It should be a 32. A 32. A 32. A 32. Right here, that's a 32. And guess what these give me? 60, which cancels out that 64, which gives me what? 63, which is the correct answer. Okay? Boom. There it is. So you got to know there's two different formulas, you got to know them. Okay? So this one here, so for geometric, S sub n is a sub 1 times 1 minus r to the n over 1 minus r. That's the geometric. That's how you find a series for geometric. If it's arithmetic, okay, S sub n is what? N times a sub 1 plus a sub n over 2. This is where we got confused on this problem right here. All right, gotta be careful in that. All right. Anybody else? Okay. All right. So today is a practice day. Practice. You're going to be practicing on identifying arithmetic, geometric, writing an nth term, finding some series for me, and then we're actually going to be looking at some word problems, applying this idea as well. So what happened to your row, Krista? I think you're right. ACTers. ACTers. 3, 4. You bet. Woo! Okay. So let's look through this together. Okay. So you'll see the first page, the first 12 problems, it says, tell whether each sequence is arithmetic, geometric, or neither. So there are some in there that are neither, maybe. Okay? Second, supply the missing terms of each sequence. Even if it's a neither, I'd like you to try to find out what the pattern was and fill in the missing slots. Then it says, third, give the common difference or common ratio and write a rule for the nth term. You would only be doing the third part if it's what? Arithmetic or geometric. If it's a neither, you're not doing the third part. Down at the bottom, 13 through 18 says, write a rule for the sequence, then find the specified term. It could be arithmetic, it could be geometric. I haven't told you which one it is. On the back of the first page, 19 through 21 are arithmetic. I'm telling you that. Write a rule and find the specified term's value. So this is like we did yesterday where I didn't give you the terms in a sequence. I've given you maybe 2 specific terms in the sequence. Then 22 and 23, how many terms are in the sequence? Those are kind of challenges. We haven't done it like that. I'd like you to try those. Try them. 24 to 26 are geometric for sure. Write a rule and find the value of the indicator term. Again, those right there, 24 and 25 are pretty straightforward. 26, that's the kind we did yesterday where you have to think about what you're going to do. I've given you 2 specific terms. And then 27, 28, 29, 30, it says find, look at 27. For number 19, up above, find what? The 20th partial sum. 28 says for number 20, which is up above, find the 24th partial sum. 29 says for number 25, find the 10th partial sum. And 30 for number 26, find the 14th partial sum. Okay, so those last 4 are referring to problems above that you've done. Now, you're not going to get all this done today. There's no way. This is also part of tomorrow's assignment. Okay, On the back, there are word problems. Now here's what we're gonna do. I'm gonna let you start working on the front. We'll probably hear in about, I don't know, half hour during the second period together. We're actually gonna do 2 word problems together as examples, and then you'll be able to do the rest on your own, okay? So this assignment is today, tonight some, and then tomorrow. You bring it back on Thursday to go over it, okay? You can get help today on anything you want. If you have a question, ask it, please. Okay, ask, ask, ask. All right, there you go. Boom. Boom, boom, boom. All right. So we're going to go ahead and just do two like word problems here that are sequence/series types of problems. Okay. So here we have a problem. Mr. Sullivan and his daughters are stacking firewood in the yard. The base layer, that's the layer on the ground, has 84 pieces. He tells his daughters that each new row of wood should have 4 less than the previous row. When the girls finish, there are 8 total rows. How many pieces are in the top row? And how many total pieces of firewood does Mr. Sullivan have? So we got what type, first of all, when you read this, you should immediately be able to identify it as either arithmetic or geometric. Is this going to be arithmetic or geometric? What tells us it's arithmetic?
Each new row should have 4 less.
Yeah, it's got 4 less. Okay. So this 4 less, that means my common difference is -4. Great. So I know in this problem D is -4. So I could write my rule right away. And why do I want my rule? So I can find out how many are in the top row. So what would the rule be? A sub n equals
84
84.
parentheses and -1.
Is there anything in between those?
Plus.
Plus, perfect. There we go. What goes in here then? N -1 and then times. Now, you can leave it like that right now. That is completely fine to leave it like that for this word problem. Okay? Because I can use this to get this answer. So now when I'm asking you this, I'm asking you to find what? An 8, right? I'm asking you to find the 8th term. So that would be whatever 84 plus 1 times -4 is. So that would be 84 minus 28. 7 times -4 is minus 28 then. So what's that going to be? How many pieces of wood are in the top row? 56. Okay, got it. Now I want to do what? This was a sequence. What's the bottom? It's a series. And I'm asking you find the 8th partial sum. The sum of the 8 rows of wood. So down here, you'd be finding S sub 8. So if I'm doing that, it would be what? 8 times what are the two things I add together? First term and the last term, right? What is the first term? 84. And we just found the last term. It is 56 divided by 2. It's always divided by 2. So this is going to give me 8 times. Inside, you're going to get what? 140 over 2, which is 70. So how many pieces of wood does he have total? 560. Okay, there it is. So that's just an example of giving you a word problem that could be a sequence / and a series combined together. You have to do both. Okay? I've got one more to do because that's arithmetic. It could also be geometric if I want it to be. Here we go. Mr. Snyder's walking through Town and Country Mall. He hands a quarter to the first kid he sees. The second kid he sees, he gives 2 quarters. Third kid, 4 quarters. Mr. Snyder continues handing out quarters to the kids he sees, following this pattern for the remainder of the day. All right. How much money did the 20th kid receive from Mr. Snyder? And if Mr. Snyder handed out quarters to a total of 38 kids, how much money, spelled wrong, did he give away in total? All right. Arithmetic or geometric? Geometric. So this is a geometric problem. What is R in this problem? 2. All right. So let's write our rule to start. A sub n equals, what's that? 1. He hands
Give
a quarter to the first kid. Okay. So what do I want to put here?
1 times 2 to the n minus
So if I put 1 times 2 raised to the n minus 1. Okay, now look, here's the thing. That's true. But look what my questions down below are going to ask for. How much money? How much money? So I could say I said I handed 1/4, but how much money did the first kid actually get? 25 cents. So maybe instead of putting 1, I should put 0.25. Because that's how much the first kid I saw really got. So I'm going to make this 0.25 times 2 to the n minus 1. And that means the second kid got what? 2/4, which is the 50 cents. So it's going to work just fine for me, right? All right, here we go. So the 20th kid would be A sub 20. So that would be 0.25 times 2 to the 19. So now you want a calculator out. And I didn't do this problem yet. So you're going to have to help me out here. Tell me how much money I gave that 20th kid.
131,072.
How much?
Yeah, I got a.
You're going to get a big number. It's huge.
131,072.
And 70, so 0, 7, 2?
Yeah.
Is it exact?
Yeah.
Yeah, okay. That's a lucky kid, right? Not as lucky as the last kid I'm going to give it to, the 38th kid. Okay. Okay, here we go. How much did I give out overall? Now I'm finding what? The sum of 38. So, bless you. So if I'm asking you, if I wanted you, like, let's say this was a quiz or a test, I would ask you to write down what you're doing for computations here. Just fill it in. I don't need to see all the work. I just want to see it. What would go here? Again, this is like last time. What goes here? First term, 0.25 times 1 minus what? 2 to the 38 over 1 minus 2. And then you can just do this on your calculator. Okay? I'm going to have to work the rest of my life to pay this off. This is going to be a massive, massive, massive number. Oh, actually, I loaned my calculator to somebody today. I was like, where'd my calculator go? I loaned it to him for the ACT. You get one. You have an answer? Let me have an answer. I can just look off their calculator and get it. You have it?
Mine said 8.
Yeah, that's it.
Yeah.
That's it. Okay, here we go. It's going to be in scientific notation. Okay? Which means I take that decimal point and move it 11 times to the right. So 2, 7, 4, 8, 7, 7, 7, 9069. And the decimal was right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have to add a 0 on there. Yeah.
You
You got something different?
We got 6.87.
I did.
You see what you did on there? 1 minus 2, 38. Did you do yours on the calculator? Or so you got the same thing she got, or you got the other? Oh no, you got this. So you guys got the same thing. Did you just forget the rest?
Is yours negative?
Oh yeah, you did. You did. Let me have. Have this. Yep. It is 6, 8, 7, 9. Oh no, 719. 476. 476. 736. The decimal was here, move it 10 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's bloop, bloop, bloop. Oh, look at that. I gave away last year's pay. $68 billion total. Isn't that insane? If somebody walked around and did that, just gave away quarters like that and doubled the amount for 38 kids, they'd give away $68 billion. Yeah.
Mine's negative.
Yeah, what is it?
It's all about how you type it in.
He's getting-
Because I got
You should have a negative over a negative and get a positive at the end. And if right, this should be a negative divided by a negative. Oh, it's because this is not, this is dividing by 1 and then subtract, that's why. So yeah, so see, crazy. If you just like, if we're gonna guess, you would never guess that was how much money that was. All right, so that's an example of a geometric type of word problem. Sequence / series. Okay, so you guys are working on the sheets today, tomorrow. I will post the answers sometime, probably tomorrow afternoon. And that way you can check them, and then you can actually go ahead and come back in Thursday and ask about them. Thursday, I will tell you right now, and I'll post it as well. Thursday, when you come in, there will be a quick quiz on geometric and arithmetic sequences and series. It'll be identifying like the basic, like is it arithmetic, is it geometric? It'll be a basic. It won't be something real crazy at all. It'll be kind of a quick thing, okay? And then we'll probably go ahead and just do some extra practice. And I might have some more word problems that we will do in here as well. All right. So there you go. That's what's going to be going on. And yeah, I like it. That's good. That's good, good, good. Yeah. What's that, man?
So, is this right on?
So this is r cubed is 96 divided by negative 12, right?
I got to that. I got my raise by just guessing actually. It was only -2. So what was the thing? I got stuff like this stuff right here. What is that?
Okay, you don't have to worry about millimeters because if you take a cube root it only has one possible root, positive or negative. It's when you take an even root, you have to do both positive and negative. That's why I didn't give you that.
Okay, so
That's why this one is a single. It's only going to have one possible answer.
was it 96 over?
Yes, and that's going to give you a negative,
Oh.
and the cube root of a negative is a
I did negative.
negative.
I did -12 over 96. That's why.
That's backwards. Shop ba 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 boo. Woo! Bum bum. Good luck on the ACT tomorrow for those of you who are taking it. Hopefully that'll go well for you. Okay, I'm going to stop that.